Okay, so let's get started. So for today, like I said, since people were just coming in, I just repeat myself again quickly. So for today, the important thing is that here I posted, since I'm sure all of you like to have your deadlines and your deliverables so you can plan a little bit better. I have posted the due dates for the labs and the project as well. I want to stress and emphasize, even though you may not feel this way, but the only reason I give you labs and projects is not to torture you and take up your time, but to give you something hopefully mildly fun to do and something that allows you to test that you've understood things, etc. Right? So it should be less of a pain and it should be hopefully fun. But of course, let me know what your experience is. So having said that, um, then if all of us can go to the main page on the course website and go to the section called the first session we did, in there is a section called data persistence lab, right? So if you click on that lab, then on the link below it, it will take you, yep, it's coming up. So all the instructions for the lab are here. And if you click on this view resource in a new window button, it will pop up a new tab. Okay, look like this. Well, it won't look like this for you. What we'll have for you is there may be a sign-in option in this blank region. Now, can somebody confirm that's what you see? You should see something that says sign in or a link like that. Is that what you see? Somebody can let me know on chat. Anyone? Yes. So here, unfortunately, you have to create a login. So please go ahead and create a login. You don't absolutely need the login, but the login will allow you to save your work and come back and continue working and so on. If you don't create logins, your work will not get saved. So please create quickly. It will take only a minute. Take a minute and create the login. Okay. So once you've created the login, just one caveat again, make sure this is a web-based user interface. So if you're working on anything, make sure you save things as you go. Now, I'm showing you a new interface. So I guess the first question we should ask is, why am I seeing the new interface? And the answer is that this is the typical programmer's interface, right? In the sense that there are a bunch of files, they're all Python files, and if you join any company or in workspace, you're going to find that not everything is done in notebooks. And the reason I introduced you to notebooks is that there's a lot of data science that's done in notebooks. But at the end of the day, if you are having to work, industrial strength programs, a lot of it will end up in coding solutions that look like this. That is point number one. And point number two is I've tried to make it so that your code can be written here and submitted directly from here. And so today I'm going to show you how to write code and submit it. And you can't really submit a Jupyter notebook easily. Okay, so I tried to make it feasible for you to write your code and submit it easily. And my hope is I don't think I put any cutoff into your submissions. Okay, so you can submit and make sure that you're getting good grades and so on. So I'll walk you through that workflow. But of course, the goal here was never for me to make you submit your code to see if it is correct. Because when I was taking courses like this, like you, I found in many cases that they will make me submit my code and then they'll tell me there's a problem and then I don't know what the problem is. And so it takes me a long time to fix my code. So I tried to remove that problem. I don't know if I succeeded fully, but you will tell me. Okay, so so that was my design challenge, right? How do I have an assignment where the students can write code and they can check for themselves if they're doing well. And if they know that they're doing well, then they can submit and get, as high grade as but they should know their grade almost before they submit. So how do we do all that? And the idea is here, I'm showing you how you could set this up for yourself, right? And that all brings us back to understanding one simple concept. So let me go back to the web page because I think I put some notes in the appendix here. So if you go back to the course web page quickly, By the way, I don't know if I can ask a quick question, but you can tell me on chat. Have you found the website easy to navigate? Are you able to find things easily there? Somebody let me know, okay, on chat. But anyway, at the bottom, hopefully you should see a section called additional material. Do you see, does everybody see it at the bottom? There are some extra sections on my page, but that's because I'm designing some new stuff for you. But at the bottom of your page, do you see a section called additional material? Somebody can let me know on chat. Okay, so if you click, let's go in, there's a section called testing your code. I just put this in as additional material for you. Maybe it's a good moment for me to ask this question. So I don't know, let's see if this polls will work. Do you guys see a poll? I'd love to know how many of you are familiar with unit testing. Okay, so there are no unit test gurus. Okay, so maybe this is also an extra bonus for you, right? It's part of, it's probably good for you in your, it's probably, at least a couple of you know it. So that's also good. If you want to jump in with any comments while I cover it quickly, please do, okay? But this will be useful for you when you go to, let me just share the results. So if you go to your job or something, they'll ask you about testing. Sometimes in interviews, they ask these questions. At least you can have some familiarity with it. Okay, so let's click on this section here. It says testing your code. And I'll try to give you the 2-minute version. I think actually maybe a 2-minute. Okay, there are some more polls here, but we'll ignore them. So the basic question is, how do you write tests and what is a test, right? And the answer, I've written a lot of words here, but I'll just talk about, because I think you should read this section, okay? I just put this up on the screen so you should, you can read it at leisure, because it is a fairly big topic and people have written books on it. I don't want to take you into the elaborate version. I want to give you just enough so we can use it. So the most important thing that I keep repeating to people is this one line here, right? Every test has this flavor, right? It says something is equal to something. And if the equality is true, then you pass the test. If the equality is false, then you fail the test. So this is basically the idea, right? There's always a left-hand side and a right-hand side on that equation, right? And what we do in Python is we take this concept and we use, you can see here, I will highlight this thing here. In order to enforce that equality, we use this assertion. You assert that something is equal to something. And that assertion often will succeed and sometimes will fail. If the assertion fails, then you fail the test. If the assertion passes, you pass the test. And I'm trying to say in a short form, maybe that's all we need for this moment, okay? So I repeat again, so we just basically, our testing almost always is going to consist of comparing something to something. And to check if the comparison works or not, we will use an assert function, right? And the assert function is available in many libraries. We will use the Python as a built-in framework called unit test, right? A unit test framework. You can find a lot of documentation. If you read this thing and click on some of the links, you'll get some interesting stuff to read. So maybe one of these days you can look at it. But today we are going to just take this as background. And we are going to go straight into, let me see if I put anything more here. Yeah, just about unit tests. So let's just go through these 3 or 4 things. What does unit test do for us? It gives you a standard template. As I said, assert equal. I'm going to show you how I use that template. Then you can auto run these tests. That is also a nice thing. And I want to stress this for those of you who are saying, yeah, I check my code anyway. Why do I need a test framework for this? The idea is every time you check your code, you have to really make sure that the left-hand side and the right-hand side match. It's not a programmatic check. It's a human being check. And even though you don't realize it, few minutes are spent every time you check something is equal to something. And so this testing framework idea is that we can automate all that, right? You have a bunch of tests. Every time you change your code, you can just basically tell the computer, please check everything is okay. And this is the reason why it's heavily adopted in the industry. Okay, so much for parenthetic comments. If you have questions, you should ask me, okay? But now let's get back to where we were. So again, just a recap for those who joined, I'm trying to go through how do we do the labs. So I'll just give you the navigation. Go to session 1. go to Data Persistence Lab, go to Programming Lab, and then at the bottom of the page, you have a link. You click on this link. It'll ask you to do a sign in, and it'll bring you to a window which looks like this. Okay, I've done that enough so everybody's caught up now. I did it quickly. But if you have any trouble, just chat me. We'll see if we can troubleshoot as we go. Okay, so now what have I done here? So remember the first lab, the first session was all about databases. And so this lab is about doing database code. But before we go to databases, let's look at this testing idea first. But even before we get to testing, let's see how do we actually do anything in this interface. So let me see. So there are, on the left-hand side, you see there are folders. There's a source folder, and inside the source folder, there is a bunch of files, right? So let's focus on this file called main. So main is a simple Python file. And if you have, you should see something like this. Here, there's a section I don't want you to touch. Okay, so let's just ignore that section for now. And if you put anything in here, so let's just get started. Just say print hello. Let's make sure we can actually run something. If you say print hello and hit the run button, you see on top there's a run button. If you hit the run button, you should see it. The first two commands are coming from me internally. Okay, don't worry. It's actually creating a database for us to work with. But whatever I put in main gets executed, and you see the output here. Okay, so it's fairly easy. Hopefully you're able to start writing code right away if you have things set up this way. Okay, so that's point number one. Point number two is, let's look at this code, which I said don't touch it. This code is actually the code that is needed. Remember the students database that we talked about? This code will actually create a students database for you on the fly. Okay, and if you have questions about it, we can discuss more. But for now, take it as a black box. There's a database created for you to use. So then the next thing you do is you go to this file called analysis.py, and you have to basically implement a few functions, right, which will be the answers to questions. So where is the question? The question is here in rather gory detail. So let us make an example of this. Create a function student count that will return the number of students in the students table in the database. Okay, so I don't want to rush through this because I assume it's all easy for you, but I will do one simple example quickly and we will talk about this. Okay, so clearly you can, I wrote a little function here that does, you know, that shows you how can you query something from the database. Even before we do all this query, notice I have created a simple function for you to use. This function can take any SQL command, as long as it's a valid SQL command on our database, and it will run the query for you and return the results. Okay, so you have this function called test database, and if you run this function, we can see what happens. So if we go to main.py, then this whole stuff is sitting in a file called analysis.py. So if you go to main.py, you see that analysis is imported as a Python module. And here, instead of print hello, you can say a dot, and I have to just get the name of that function. Let's see, analysis.py, test database, right? You can take this function and put it in main, right? And just invoke it from here. So if we now hit run, it should run that function, hopefully. That function should, okay, it runs. But of course, unlike Jupyter, and I'm corrupted already by using Jupyter a lot. Even today I was typing in Jupyter. There you don't have to print everything explicitly. Here you have to print everything explicitly. But you see at the bottom here, this is the query result coming back from the database. So I have done something fairly powerful, right? In this little piece of code, I've created a database. I've written a function to query it, and then I've invoked the whole thing and displayed the results on the screen. Okay, and later you can even write helper functions to display this in a nice format and so on and so forth. Any questions? Because then I'm going to switch to testing. Is everyone comfortable? I showed you something pretty quickly, but is everyone comfortable? Anyone? Okay, good. Somebody says good. Okay, so now let's go switch to testing. Okay, so in the testing section, what happens? The testing section is, for example, I know that there are 5 students. So let us start by pretending that you are writing tests. So I think that is a very helpful skill for you to develop. So let us see what you need to write a test here. You write a function, whatever the name of the function, doesn't matter, but it has to start with the word test underscore. As long as it starts with test underscore, then unit test will run that function for you. Okay. Inside that function, you basically have to, so it's actually a class. So I don't want to get into it, take it as a template for now. You do self.assert equal. This is the assert equal I told you before. And I have written a method called student count. We'll go and see what student count should do or can do. But I know that the number of students is 5, right? So then I run this test. If this method returns 5, then I pass the test. So that's how the test itself is created, right? And you can see there are many other tests here. And your goal is to try to pass all of these tests by writing code, of course. So let's go and look at how student count looks. In analysis.py, there should be a function called student count. Right now, you see this pass is a Python way of telling Python, I know I have to write this function, but I'm not ready to do it right now. But for you, that right now has happened. So now is your time to write it. So here you would delete the pass and write the code that actually, so you can see this is a SQL, and then you can use this SQL to get all the students from the students table and then count how many records are there. When you return that number, you will pass your first test. Okay, and now let's go back here and look again. There's a bunch of tests here. These tests correspond to the questions that you've been asked to answer. Right, so you read the question, you implement the corresponding function, you find the test that's being run on it, and the answers, whether you pass or fail, or these tests will tell you. So how do I check and run all these tests? Once you have implemented something, you could just, there's a test button here. So notice there's a run button and a test button. If you hit the test button, it'll run all the tests, and it'll tell you, like, I think I implemented one method somewhere. So it says I have, it says, so if you run whatever, at the bottom, it should tell you, maybe I minimized the window. Yeah, it tells me how many tests were run, how many I've passed, how many I failed, whatever. Okay. So if you didn't implement anything, you have 6 failures. If you implement 1, you'll have 5 failures, right? Until you get 0. When you have no more failures, then you're ready to submit the code. And hopefully then when you submit it, you'll get 100%. Then you click on this green button, submit. The code will automatically get submitted and your grade will be updated. And you'll see the grade right here. I want to tell you that the grading is done here. When it says 1 point, it's actually 100 points. So if you get 1 out of 1, that means you have 100% on this thing. Okay, and I think for all of you, the goal should be 100%. So try to work on it. If you have any problems, ask me, etc. Okay, that's all I wanted to say for this. But if something looks not clear, maybe you can ask me. I'll take a minute. I'll pause for a minute. Anyone, any questions about your labs? If there are no questions, that means you're all telling me you're going to get 100%. I will assume so. Yes. What is the question? I see the code. What is that? Oh, yes, good question. So that was, I assume it's in this file. Let's see. Oh, in this file, sorry. Yes. So this is important, right? So this is a trick, but it's an important trick. I do not want to use this. So I don't want to use this test. So if I put a triple quote like this, so does it, somebody should know this. Let's ask it as a question. Who knows what a triple quote is? Other than the person who asked the question. Thank you so much for asking the question. But yeah, a lot of you thought. So it's comments, right? So the point is, it is a comment. So let's see, Python has 3 types of comments. There's the hash, which is a single line comment. There is the weird thing, which is the triple quote. Well, actually, I shouldn't say 3 types of comment. There's 2 types of comment. So this one is very interesting. The triple quote is actually not a comment. It is actually a multi-line string, right? So a double quote in Python is a single line string. Well, you can put line breaks in it, but a triple quote is actually creating a string. right, of multiple lines, where the triple quote covers or spans multiple lines. So if you put the triple quote around a piece of code, this is a hack that has become like a Python metaphor, right? You put a triple quote around a piece of code, this whole thing becomes a string, and then Python will just ignore it. So this is why some people said it's a comment. It kind of functions like commenting out some code. So that's what triple quote will do. Hope did that answer your question? Hopefully it does, yeah? It's kind of a roundabout way. There's some other languages, like for example, if you work in C or something, you have slash star, star slash or something like this, right? This will allow you to do multi-line comments. But there is no construct of this kind in Python. And so I think people just use triple quotes to comment out large sections of code. Okay, cool, cool. No, there are no bad questions, right? 1 second to think about it. Maybe somebody didn't realize it was actually a string. So you can actually assign this. You can say x equals this, and it'll actually be like a string. That's a whole nother discussion. What do we do with code inside strings? But anyway, so for now, I think the short answer is it becomes like a comment, and that part of code is not going to get executed. So in this case, this particular test will not be run. Okay. So yeah, so have a try. Any other, that's a great question. Any other questions? Okay, so I will close this topic for today, right? So now you know there are 2 labs. There's one lab here and the other lab is coming up after today's session. You'll be able to, I mean, you can already look at it, but it's in the section which we're going to do today. But okay, so there was one more small topic that I wanted to quickly get out of the way because I didn't cover it. I meant to cover it when we did the first section on databases. And that is, how do I read and write from files? And so I thought I would give you that quickly because the answer in Python is very simple, okay? The answer in Python is in order, so here's a little piece of code. So where is this code living? This code is living on the same website as we did the intro to databases, which you cloned already. In there, there's a file called file.io with Python, right? So if you go and look, you can launch that notebook and look. But I'm only going to take 2 minutes, so I don't think you need to spend time to bring this up. Just listen as I explain, then later you can go and run it, okay? I'm just telling you where to find it. So what's the idea? Suppose I have some data. In this case, I have a list, and I would like to put it into a file. So I pick the name of the file. It's in a folder called data, and the file's name is test.csv. So if I want to write this data into this file, in Python, it's actually very simple. You just call open, and open is an interesting function. It takes the name of the file which you want to open, and it takes a mode parameter. In this case, I want to write, so the mode is write. Okay, then there's a read mode and a read write mode. Okay, but usually you'll use write or read. Okay. So you open this, you get now, although this is a file name, this thing on the left-hand side is actually a file handle. That means you can do operations on it. In particular, there is only one operation which we would want to use. So in particular, you see this here, I called print on that guy. You can see it's some kind of class. But you don't have to get confused by the fact that it's a class and all that. On file handle, we can say, file handle, please write something for me. And that's it. That's all we need to know. So 2 ideas. Open the file. In the file mode has to be set to write if you want to write it. And then you can just say file handle.write. Now, the extra piece of code here is, because I have multiple elements and I want to put one element on each line, I call file handle.write. And notice here I use /n. /n is the end line character. So that will write everything on a new line. Okay, and that's it. And then you close it. Yes, that's an excellent question. Somebody asked the right question. We should, in fact, we want to use pandas to write to CSV. So with apologies to all of you, no, I think you should just know what happens under the covers, but I don't want you to use this low level thing. Most often you can just work with pandas. I don't know, there may be some use cases where you have to go down to files. Since it's only 2 lines, I thought you might as well know. But the question that was asked is a valid question. I want all of you to probably just do pandas, okay? The only other thing with pandas is useful when you have a data frame. This file open, file close is useful when you have all kinds of things, right? So you might have just a dictionary, or you don't have to convert everything to a pandas object to write this way, right? You could just have a piece of text and you could write it out. So in some other ways, this is more flexible. But very good question, excellent question. Yeah. Please keep those questions coming. They're beautiful. If you have that question, I'm sure somebody else has. And if they didn't have, now that you asked the question, they're going to be thinking about it. So those are beautiful moments. Okay. So one important thing here, make sure the file handle is closed. So this in a nutshell is the ability to write to a file. To read to a file, you just go and say read. Okay. But I want to show you something very important. It's a Python metaphor. Because you have to remember to close the file, that's something we forget, and the file can get locked and all that stuff. There's an interesting metaphor. I don't know how many of you have used it. If you have used it in any other context than files, let me know. But this is called a context manager. So you can write code which looks like this. You start with a width, and then you call the command, and you assign the return of the command in this one line like this. And now you have an indented block. What is really cool is in this context, you can operate on file handle. As soon as you come out of this context, file handle will be closed automatically and garbage collected. So Python is saying to you, if you work with the context manager, then it will take care of everything for you. Right? So if you haven't seen this metaphor, of course, you can ask me in email, but it's a very powerful thing. And it avoids us from having bugs like forgetting to close files. So I would say this is the correct, kind of quote unquote Python proper way. The previous code also works, but this is a Python proper way to write stuff. And now the last thing I want to tell all of you is notice how the code I'm showing you is always 1 line, 2 line, 3 lines, because we use the correct metaphors. Everything comes out good. As soon as you understand something like this, you should take that code and package it neatly into a small function like this. And if you look at any of the sample code that I share, you might see this pattern. Of course, I'm trying to teach you ideas, so I don't always write this. But certainly when I'm doing my day job and doing engineering, everything is packaged neatly. And this allows me to not have bugs by writing new code every time. And also, if I fix it, I can fix it in one place. Okay. So that's it. So this is the function to write files. You can look at the code. It's pretty simple. And the same thing for read files. Slightly different syntax, but that's it. So I think we can close this thing. And there's a little exercise for you here you can do. You can try to read some company data and do some calculation with it. Okay. But that's about it. So I'm wrapping up this. Let's go to Pandas. Okay. Unless anyone has any questions. So for the Pandas thing today, if you go to the course web page, let's go to the Pandas section, which should be processing data. I think it is. Yeah. Intro to Pandas. Did we have, okay, so let's see. So a quick question for Pandas. Actually, let me see what you guys feel. So, okay. Can you guys see another poll from me about unit tests? I'm curious. What do you think about unit tests? Can you see? Okay, some of you need practice. I expect that, right? If you need some more practice, that's good. Okay. Okay, so I won't take up more time. So I will ask you similarly a question about Pandas then quickly, so because I want to know how many of you actually have used Pandas before. So let's see, how does this look? How many of you know Pandas? Well, that's kind of sweet. Let's see. Okay, so 60-30. Okay, let me end polling and share results. If you can see. Can you see the results? I think you can see the results. So yeah, so what I'll do is this. For those who know Pandas, think of it like a refresher, okay? And for those who don't know, this will be your intro. I've tried to arrange it. Okay, so let's go get started, open up the notebook, etc. So if you go to, so is this poll blocking anything? Or, okay, I'll just stop it. Okay, so if you go here on the website, Introduction to Pandas, there's interactive session. If you click on this one, it should bring you as usual to a notebook for the live session. So open this guy. And then all of you should follow the usual protocol we have, right? Make sure you're logged in. Make sure you clone this project so you can have this whole thing for yourself. And then make sure you hit run. It may take a moment. By the way, there is a, I don't know if this is the moment to mention it, but I'll mention it to you because it hit me today for sure. Anyway, the notebook I want you to open is the notebook which says Introduction to Pandas. Okay, let's open that notebook. There's a bug on the website here, the Azure website, that sometimes the cache, the browser cache can get stale. And then you'll get some XSRF cookie not found problem error. You'll see it up here on the top. The only solution to, and usually it happens if you leave a notebook running for too long and don't close it. So anyway, if it happens to you while you're trying to do some work and you cannot work on it, the only solution that I know is to shut down your browser and or after restarting the browser, clearing the cookie cache. If you need a tutorial on clearing cookie caches, send me an email. Hopefully it won't bother you, but if it happens, at least you know you're not doing something wrong, okay? But when it happens, it's bad because you cannot run the notebook. Okay, so now let's talk quickly about pandas and get started. So the main points here, right? We want to work, last time we worked with NumPy, and NumPy would have been enough. There would have been a different world. NumPy would have been enough for most things, except that NumPy is probably adequate for mathematicians. If you have just matrices and vectors, or something like this, matrices in higher dimensional objects, but they're all numeric in some sense, NumPy was kind of adequate. But what we want is really matrices, but like spreadsheets, right? We want to have columns, and you want to say the first column is the student ID or whatever, and the second column is the student's date of birth, and the third column is something else. So you want it to behave kind of like a database table, and these column names and so on become metadata, right? And you want to write code that uses that metadata heavily, right? You want to say select all students who, or whatever, filter and give me all students whose date of birth, where date of birth is part of the metadata, is greater than something and so on. And that way you get more expressive, right? And so pandas is trying to solve this problem, right? How do we have, so two problems here. How can we work with multidimensional data? And then how can we get all these patterns, filtering, sorting, grouping, etc., using metadata where possible, right? And then while all this is happening, hopefully under the covers, they can also create performance, right? So fairly complex use case, but when I think of writing the code, it's not that crazy, okay? But still, it's a good piece of work, and it's pretty much gone viral, right? Everybody's using pandas these days. Okay, so let's get started. The most important thing here is this one line, right? Import pandas as PD. And that's just a convention. Everybody writes their code with the, in Python, it gets pretty standard, so the code looks the same. So import pandas as PD. That's the only thing you need right now aggressively. But I've put some extra imports here that I'll use as we go along. Okay, so now to get started, I'm starting with, so pandas has two data structures. It has a structure called series and a two-dimensional data structure called data frame. I have a separate notebook on series, but I thought we'll start with the two-dimensional case, and hopefully you will tell me the one-dimensional case is obvious. But let's see, we can also talk about series in particular, okay? So now I want to tell you that in order to get started with something like pandas, we're going to work with a data structure, in this case a two-dimensional or let's say two-dimensional data structure. The first question you must ask is, how do we create this data structure? And usually that's a good question to ask whenever you have a library which introduces us to a new data structure. There'll be some quote-unquote creational patterns. And if you know a few of them, it'll make your life easy, right? So what's the creational pattern here? Let's see. So for example, here I have 3 lists. And if I have 3 lists, you could think of each of these lists as a column in my multi-dimensional data structure. So I take those 3 lists, and you see here I made a list of lists. So that is a basic creational pattern. A data frame can be made out of a list of lists. So let's just run this code. Make sure you run the cell 1 first so that all the imports are in. It might take a little bit of time because that matplotlib import can be slow. Okay, so let it run in the background. As I keep talking, we'll wait for it to finish. It probably is the same for all of you. Hopefully it will run in a minute. Okay, so the first creational pattern is easy, right? You can create the multidimensional data structure from a one-dimensional data structure from a list of lists by using the data frame, okay? But the important thing is that the data frame right now has no metadata. Why does it have no metadata? Because I didn't give it any metadata, right? So then pandas will just basically default. The metadata will be just integer values. I do not know why it's taking time, but okay, it's finally finished. So okay, then I can show you what is happening. Notice the column names are all integers, 0, 1, 2, and the rows are also 0, 1, 2. Kind of like a naive Excel spreadsheet, right? It auto increments. But now we see the concept in pandas. If you ask pandas, what is the index you're using for my data frame? It says, well, I have a kind of index for you. It's called a range index. It's exactly mimicking Python's range, but it's now used as an index, right? It has a start value, a stop value, and a step value. So it starts at 0, stops at 3, and steps by 1. So that is what you would have expected. What you may not have expected is that the columns also have an index, which makes sense now that you see the display. And in this case, because it's a 3 by 3 array, this particular set of indices makes sense. And that in a small part of the story is the way to get oriented with pandas, right? It's an indexed data structure with 2 indices, row indices and column indices, right? And if you keep that in mind, I think things will start to get easy. But of course, interrupt me with questions if any, okay? I do want to say one important thing. I want to keep this interactive so you can type as I go, but I am also trying to introduce you to some concepts in pandas, and I'm trying to introduce you to some important patterns. I'm not trying to walk you through the whole library. That you can read the documentation, okay? Hopefully at this end of the session, you should have some clear concepts, the ability to do at least the things in the notebook. In this case, why do we say, oh, beautiful question. Somebody asked, why do we say stop 3? That takes us back to Python, right? Python, the stop index is always 1 more than, because Python starts counting from 0. So there are 3 elements. If you look at the numbering, you see it starts 0, 1, 2. So Python always gives the stop as 1 more than the last value. And that is a long story. Why does Python do this? If you're interested, send me a note. I'll send you an email, okay? But by the way, this is not a trivial thing. So it's a good question. This concept is central to Python. In many places, the stop index will be always 1 larger than. And the reason it's 1 larger than the size is because we start from 0 and not from 1. And so it's the source of many bugs, right? Especially if you come from other languages. So anyway, and there's some philosophical comments as to why that is the way Python chose it. But for now, we don't get to fiddle with that. So, no. So, okay, so let me show you this quickly. Since somebody's asking this question, by the way, all of you, of course, others who know can jump in, but let me show you something. So Python does this. There's a simple range object. Let's just play with this guy. So if I want to create a list, okay? So let's just do it. If I want to create a list, I take the range object, which is very similar to what we're discussing. The range object takes 3 parameters. So for example, let's start the list from 0. Let's stop the list at 3 and see what happens. Oops, list. Notice there's a nice little creational pattern. It allows us to create lists in 1 line, right? And populate all the values. It's really fun thing to have. But actually this thing takes 3 parameters. It's a clever little function. The 3rd parameter, if not present, will default to 1, okay? And so if you run this, you'll see it starts from 0. The stop value is 3, but it actually stops at 2 because of Python starts from 0. But now you could actually say, instead of going in steps of 1, you can go in steps of 2. And just to make this more interesting, let's push this up to 5 so you can see some more entries. And you see you get all the even values. So the step is a step counter, right? It says how big should the jump be. Is that clear? The small basic Python thing, but again, this pattern is very helpful. So it's good to have around. Is that clear or did I rush it too much? So range 0 to 5 with step being 2 would give me this output, right? It would give me all the even numbers because it starts from 0 and steps in steps of 2. Cool. Yes. Don't hesitate to ask, okay? And for the others in the class as well, if somebody asks a question and I recap something which is basic, think of it as a refresher, or think about some questions like why does Python start with 0 or something more profound, okay? and or make a comment. All good things to do. Okay, so there are no bad questions, right? So don't hesitate to ask as well. Okay, so let's keep going. So what are we doing now? So now I'm going to try to make another list, another data frame, sorry. But this time I want to basically set, so let's see. Okay, so let's just run this and see what df1 contains. Okay. So is this clear to everyone what's going on? For a moment I was like, what am I doing? But is everyone clear here? There's a trick I did. Can everyone see what I did? Or anyone, can you ask me a question? Is it clear why this code would produce this output? Is somebody should say not clear or clear? It's Boolean. Silence is not an option. Columns equals C, good. Ah, good, okay. So now that means it's not clear, right? Good question. So let me explain what's happening. If I take out this part, right? Then if I take out, let me just take it out for now. If I take out this part, it is the same code as we ran before. pd.dataframe ABC, right? ABC is 3 lists. So in fact, if I run this code, we are back to where we were before, right? You see this. But now I want to basically set up the columns and the rows, and I want to give them labels. So the columns, I decided they will all be uppercase. So I make a list. So in fact, if you want to see this, let's just run this and look at what does C contain. If you look at what C contains, you see it has 3 values, A, B, and C, right? So these are going to be my column labels. So in the first line, I created the column labels. And now since you're such an expert, I decided to do the row labels inline. I didn't even create a variable for it. So in fact, if you wanted to get sophisticated, I could do it this way, right? I could just put it here like this. I created a variable just to show you what was going on. So notice that so let me write this because it looks symmetric. So notice the data frame has 3 lists for the entries in the rows, three lists of values for each of the rows. The column is going to have the labels ABC, capital ABC, and the rows are going to have the labels little ABC. So let's see. Kind of Excel spreadsheet like, right? There's a row and a column label, okay? But even though I showed you with ABC, this is a nice pattern, right? Because then instead of ABC, you're going to have student ID and student date of birth and all kinds of descriptive columns. So that would be very nice and interesting. We'll see an example in a minute. But this picture is very important, right? So we can create a data frame if we have the data inside the data frame as lists, for example. If we have the column names and the row names, then the data frame can be manufactured. And then everything can be done after that. Okay, so it's important. It's little kind of fiddly in the beginning, right? Just to create a data frame, what you have to do. But once you do this, now let's go and see what is the index on this data frame. And you see it says I have an index and now it's A, B, and C. And if you say what are the columns, it says I have A, B, and C as columns. And in a minute, I'm going to show you why these index and columns are useful. Because if it's not useful, this is too much headache for us to work on this, right? So let's continue here, but I want to show you another example here, which is helpful. So here's an example where I created some data. So populations, there are 3 values for populations. Area, there are 3 values for area. And actually these populations and areas are populations and areas of 3 cities in 3 locations in New York State, right? So New York City, Buffalo, and Poughkeepsie, 3 locations, right? And the idea is that, oh, I would like to work with this geographic data somehow. I tried to run it with names for the columns, it didn't work. Okay, can you just type the code which did not work in the window? I'll debug it while we go. Just type me the code that didn't run, okay? I mean, of course, I can also show with names for the columns. So does anybody want to do names for the columns? So let me just do it now since we're trying to do it together. So what we have to do is be a little less clever then. If you want to give explicitly names, you do like this. You take columns, and it has to be, let's see, A, oops. And let's see. It worked. Now ABC is boring. So what else do you want? I don't know. I'll just put some extra characters in there. I'm not sure what we want to do with this data set, but hopefully that took care of it. Yeah, no problem. No problem. It's interesting for me to debug these things as we go, but it's important, right? Otherwise you'll have a question in your mind and you'll be stuck trying to figure out what is going on. And if you have this question, I'm sure somebody else has it. So don't hesitate. It also keeps it nice and interactive, right? I'm not just a talking head. You can ask me something. And of course, I keep repeating to all of you, I'm here to help you, right? So please ask. It's my pleasure. Okay, so notice that, of course, the column names got changed, but if you ask it what is the index, then the index got refreshed as well, right? So now we have actual indices. Okay, so anyway, so the point here, which I was talking about populations and cities and so on, is notice how this data has already become a little ugly. If I want to know what is the population, think about if I don't have a data frame, if I want to know what is the population of New York City, it's kind of annoying, right? Because I have to remember New York City is in location 0. Then I have to go to the population thing, find location 0, and area, find location 0, and so on. You'll have all these patterns to access stuff. But now that we have pandas, we don't do that anymore. We just say, okay, I'm going to make a data frame. And notice what has been done. The data is passed to pandas. So pandas, previously I showed you how pandas took a list of lists. Just to recap quickly, because it's new. Here is a list of lists. Pandas can make a data frame from a list of lists, or it can take a dictionary. So in this case, I passed it a dictionary. And because I wanted the index to be the city names, I passed in an index, which is the list of cities. And now let's look at our data frame. Data is not defined, so I have to make sure that the cells are run in sequence. Okay, it happens once in a way with a notebook. But now we got a nice little Excel spreadsheet-like thing. But what is interesting is we have 2 indices now. Notice I have an index on the cities for the rows, and the columns tell me what are the data I have stored, population and area. And all the values, actually, if you extract the values, you can do cities data.values. You get back what we learned last time. You get back a NumPy array. So that is the magic here, which I want you to all appreciate. Underneath pandas, it's actually said, okay, I will not design a new data structure. I will leverage whatever NumPy has tried to do, so I can get all of the performance benefits of NumPy for free. Right, and that's going to show up very helpful. Okay, I arranged it this way. If anybody wants me to change, so do you want me to answer the question? Maybe I'll do it later. So okay, I was going to say, do you want me to answer the question, what do I do with all this index stuff? I'll show you in a minute. Okay, so anyway, but first thing I want to tell a minute or two about these indices. So when you have a data frame with indices on it, we can actually do the indices support Boolean operations. So this is very important, right? You can do ands, you can do ors, you can do all kinds of operations on the index. And once you do an operation on an index, it makes another index, right? So for example, look at this operation here. So let me just create this data frame. So this data frame is the one we created before. Now notice here, the index has the values A, B, df1 has the index A, B, and C. That was the one we created before. This one has the index A, B, and X. So if I say what is A and B, that means it has to be present in both indices. There are 2 indices here, one on df1 and one on df2. If you say A and B, notice how it gave me the common values, right? So now I have a very powerful way of finding out between 2 data frames, what are the common values. And once I have the common values as an index object, I can go back to the data frame and give the index object to the data frame and say, can you please reindex on this guy? And so if you do this reindex, see what happens. I get back only the common rows. See, the 3rd row is removed. And so that gives you a very basic view. This will get more and more sophisticated very quickly, but very basic view into how does pandas enable us to manipulate data using set-like operations, when the set-like operations form the basis for what we do with SQL and so on. The big difference here is everything is done in memory, so it's going to be orders of magnitude faster. Okay, and of course you don't have to connect to a database to do this, so that's even better. Okay, so that is, so I want, just as you can do and, you can do or and other set operations, okay? So since we talked about reindexing, let me throw in one more feature of reindex. If you take a data frame which has an index, let's say A, B, and X, and if you say reindex and pass in a new index, some values are already in the data frame and some values are outside the data frame. Right? It says, hey, can you please take the existing data frame and reindex it? But I will give you a new index. See what it does. The element that was in the data frame is extricated and deleted conceptually, right? I'll talk about in what sense is it deleted. But the element X will be removed and replaced with the two new elements of the index you gave it. And then the rows will be blank because there was no data for it. So where the new index and the old index matched, you got back what was in the data frame. Where they did not match, in the sense that the index you gave it, like C and D are additional values, they come in as blank values. And where there was an extra index that's not in the new index, that was removed. And now comes a very important question. Does this mean, if I run this operation, does this mean df2 has been modified? And the answer is no. What is happening is a new data frame has been created, and this is the new data frame that's on display. df2 is unchanged. And I will give it to you as an exercise. You can do it while I'm talking or whatever. Make sure you go back and run this query and then run df2 and see. It would not have changed, or it should not have changed. Okay, if it has changed, you should tell me. Okay, so play around. Reindex is a tricky operation, but maybe just to get started, right? Indexes are interesting. It's not going to be where you're going to spend all your time. So something to know, but let's keep going. So now let's work with the cities thing. So let's see some cool things that we can do right away. As soon as you have a data frame, you can ask the date. By the way, for those who have been, I think many of you have done R before. In your mind, you can do, I did this a long time ago, so it's not fresh in my mind. You can start making comparisons between R data frames and Pandas data frames. And any of you can tell me what you think. They should be almost equivalent, but okay, some corner cases and some differences are different, okay? Similar flavor though. So if you already know it in R, you can come here and say, okay, I think I can be productive fairly quickly, okay? Okay, so if you have, there's an info, and maybe the names of some things may be slightly different, okay? But okay, if you do cities.info, you'll get, some information. It's more interesting when you have a larger data frames, but it'll tell you how many values are there. It'll tell you if there are any nulls. It'll tell you what is the data type. Is it an integer or is it a float? Right? And actually something that I pay attention to, but not everybody cares, but when data frames become big, it's important is how big is the data frame. There's also a function, this is more statistical. If you say describe, it will give you, summary statistics. So now you can see already, if you just load up the data in a data frame, it's pretty clear how we can get summary statistics for free. Next, which is the interesting part, is okay, now that we've done all this, we create all these indexes, blah, 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 how can I get stuff out of the data frame when I want it, right? And so the simple thing that we should remember is the square bracket, right, is the bracket operation is the key here to getting things in and out. But it's actually, we're going to get square bracket on steroids here. It's going to do a little bit more for us, but we'll go step by step. So, but the pattern I want you to think is square bracket has two parameters. It has a row indexer and a column indexer. Now you can see why I introduced you to indexers before. So it takes a row indexer and a column indexer. Okay. And so now let's use this concept and say, okay, how can I do various selection patterns? I would say that if you can get the selection patterns under control and you can select anything, then you are well on your way to having fun with pandas. Okay, initially all of these are kind of fiddly. Okay, so let's start by selecting columns. So notice here, I want to select a subset of columns. If you just look at df1, let's just have df1 here for reference. if you just look at df1, it should have 3 columns, right? And in this case, okay, I have to update. Okay, maybe I will just reset my df1 to have AA, so I don't have to type double A everywhere. Let's see, where was my df1? Give me a second. Yeah, how to navigate quickly to the place. There it is. Oh no, that's not the one I wanted. This is the one. This is the one I wanted, but with single index. Yeah. Okay, so I'm back to what I wanted. So let's just go back here and just look at this section which we were in. df1 has a single letter column, right? A, B, and C. And I would like to select the columns A and C. So all of you can just do it as I'm explaining. You can do it for yourself. The answer is you have to pass in a row indexer and a column indexer. That's what I told you. Now I broke the rule right away. Why did I break the rule? Because I want all of the rows. So by default, Pandas says, okay, if you want all of the rows, you don't have to tell me. I know how to give it to you. So I don't have to specify all of the rows. And it's kind of biased, right? It's biased in the sense it's automatically looking for columns. You could have looked for rows, but it's not looking for rows. So this is where the confusions come in Pandas. And you should decide, each of you, how you want to explain it to yourself and keep it in your working memory. The pattern to access columns is so popular that you could just put a list of column names here and it would just work. Okay, so let's start with the simple pattern and keep going. But what about if I wanted rows? So if I wanted the 2 rows, let's say A and B, let's keep it symmetric for now. Then you would probably, so let's even do better. Let's do a slice, which is what I had. So you can get 3 rows if you want. You want 2 rows, you can do 2 rows. The slice is contiguous, right? I don't have to type all the values in between. Notice again, I keep pushing all of you to go back and refresh slices. Work with lists and slices and make sure that it's like second nature to you. When I think I mentioned this before, when I came to Python, I thought I would get away by not learning slices. Didn't work that way. It's all over the place. So you might as well just take 15 minutes, half an hour, whatever you need, just master slices, okay? They'll be very useful too. But anyway, the point is, notice I did something very important. To switch from rows to columns and use slices like this, I did this concept. Around the square bracket, I put this interesting thing called dot lock. So there are 2 things here that Pandas has subsidiary for the square bracket operation. There's lock and there's iLock, right? And so what is the difference between the 2? Lock is for index labels or index values, and iLock is for integer values, I for integer, although it could have been I for index. So I do get confused myself, but maybe you can just learn it for now. I is for index, for integer, and df1.ilock will work like this. So notice here, iLock, as I said, now it's a row indexer and a column indexer. So it says, give me the first 2 columns and all of the rows. Okay, and there's less I can say in words. Maybe if somebody has a question, it's easier for me to try to answer. But more importantly, I want all of you to just do the simple things that are in the notebook and try to understand, if you run a command like this, does it make sense? Can you explain why this would produce this? Okay, and there's a colon here. Colon means give me all rows. But if you had put something like 1:2 here, would it work? Right? This is what you should do when you practice. Just change it, run it, and see if you could have predicted this outcome. And if you see something that is not logical to you, then you should ask. Is that a plan? Somebody's got to say yes. A daunting plan, right? But let me know, is that a plan? Will all of you that's the best way to learn this though. Because the concepts are now there, right? You need a row index and a column index. You need a square bracket. If you want to use integer values, you will use iLock. In general, you will use lock for index values. Those are the concepts. So who's going to tell me that you can just play around and learn it? Okay, good. At least one person. Okay, that's all it is though. Please don't not spend a few minutes on it, because when you want to do your project or something like this, you don't want to be thinking about these indexes, right? You want to be focused on the problem you want to solve. You want to focus on your data analysis, not how can I get the second column, right? So that's why now in this course is your chance to just take some time and just completely master this. And I promise you, even though in the beginning it may be annoying, there's a method to the madness, and if you learn some of it, it'll become easy. So do spend some time here, okay? And it's nothing more than working through this notebook and making sure you can understand everything. If you do, then you'll be in a good place. Okay, and of course, if you have any questions, send me email or whatever. So, okay, there are a couple of things that are here for you to try out on your own, okay? You can do this. So I think by now slices are clear, but again, notice pandas once in a way assumes certain things. And those assumptions may be one of the reasons why people get tripped up. For example, look at this. When you have a square bracket, if you pass in a slice 1 to 3, I didn't even say iloc or anything. Pandas assumes if you pass me a range of integer values, then you want that many rows. And so this code will work. And it will give us the illusion that we understand. But then later you will be confused, right? If you're trying to get columns, you cannot get columns this way. So please do spend a minute and think about it. These are, all I can say is highlight them as pitfalls, right? So Panda says slicing. If you want to do slicing without saying loc, iloc, and all these things, I will assume it's always row slices, right? Either integer slices or index slices. Okay. And I've tried my best in the notebook to highlight everything. So please do spend a few minutes. Yeah. For 1:3, what does each part mean? Okay, no, those are great questions. Don't apologize. There are no bad questions, okay? So notice here, the 1:3 is always, you must always think of this. So I'll say this one more time. This is again a slice. And a slice, you have to memorize it this way. A slice has a start value, a stop value, and a step value, right? And if the step value is not specified, then the step is 1. Which is the most common use case, right? This is the most common thing that we do is you step by steps of 1. So this is how we should read it. Please take the data frame. So let me try to read it as I would read it. And hopefully that is the way you will start reading it. Please take the data frame, index it, give me a slice of rows which start from the first row, not the 0th row, which 0 would have been the Python's always got a 0th row. Notice the output, you can see the row which starts with A, or I can run it with 0 and you can see. If you run it with 0, start from the 0th row and give me 3 rows, right? The 3 rows starting from 0. Another way of saying it is, instead of saying 3 rows starting from 0, you can say give me all the rows up to 3 minus 1. Sorry if that makes your head hurt, but they are equivalent, right? So I'll say it one more time. You can read it as give me 3 rows starting from 0, or give me all the rows starting from 0 up to 3 minus 1. Maybe the second one is better because when you change it to 1, you cannot use 3 rows anymore. Start from the first row and give me all the rows up to the 3 minus 1th row. And if you can start reading this way, this is why slices, painful as they are, they can cause a lot of bugs because you can be off by 1. Right? So that's all it is. And this data frame has only 2 rows. It can only go from 0 to 2, right? So that's all. It's a small data frame. Did that answer your question? Hopefully it did. Let me know. Yes. Okay, good. Like I said to all of you, don't worry. Okay, these are small things. Maybe I say it in a different way and it's helpful to everyone. If it's painful to anyone also, let me know. Then I can try to go faster or we can take it offline. Okay, so don't hesitate. Make it interactive. Okay, so we're done with slices for now. Now index labels. So as I said to you, notice this is the most powerful example. If you can understand this example, well, it's not, I don't know if it's the most powerful. We'll see. These are all powerful examples. So here's an example where I'm taking a subset of a data frame. I use the loc operation. So this means I'm going to use indexed values. And the first part is, I said row index. So it says, please give me 2 values, the A index value and the C index value. And please give me from the column set, give me the values A and C. Does that make sense? And that's the most powerful one because here in the list, I can specify any subset of index values that I'm interested in. Okay, so that is the most powerful one. Then you can see the stuff I told you. If I want all rows, I could take out the row indexer, and for example, I could put a colon here, and it should hopefully work and give me 3 rows. Notice? So if I wanted only 1 row, then I would just go back here and just take out the C value. And this is what you should do when you're practicing, okay? Just play with this a little bit, that's it, right? And challenge yourself to get all possible subsets out. And then once you're done, then you're done, right? So this is the first example, the most powerful example, so I'll leave it like this. This allows you to get any possible subset because you can control which row values are included and which column values are included. Separate question, how do I generate those 2 lists? We'll see that also as we go along. The only other thing you can do is if you don't want all of them, you can use slices, right? If you want subsets, you can also select them by slices. So slices will generate a list which looks like this, and then pandas will use it, that's all. I think that's all I want to say about, because this log thing must be making everyone's head hurt by now. So let's go to something more fun, okay? Hopefully a little friction and then it'll be easy, okay? So now it becomes more interesting. Rather than generating all these things, let us ask a more interesting question. This is the kind of stuff that we would do when we do our data analysis. Can I get all the values in column A which are less than 1.1, right? So there's some criteria. And I want to use a criteria to select subsets. That's more interesting than randomly picking the 3rd row and the 1st row and so on, right? I want all the countries with population less than some million or something like this. So the way to do that is a 2-step process. First, you set up the criteria. And the criteria is take df, take the column A, and then just give me everything which is less than this. And see, pandas is already powerful. If you do this, it's already figured this out. See, it says, you know, which values are less than 1.1 and which are not, okay? So if I said less than equal to, this will change. And if I said less than 2, it would change, right? So it's actually computing this on the fly. Already you should pause and say, if I had to do this with a for loop in Python, I would have to write some code. So already this is powerful. Now you take this, you see what the output of this is, what I like to call a Boolean array, right? It's an array of Boolean values, trues and falses. If you take any Boolean array and you pass it to pandas inside the index operation, notice where the index, where the square bracket was before, where we were passing labels. So let me take this thing out so I can highlight that space. Inside the operation, if you pass in any Boolean array, so I could have just typed true, false, true, false, true, false, too, but that has no semantic meaning, right? So this has meaning. It's all the values that are less than 1. It is this Boolean array that gets passed in there, and then pandas will automatically filter for us, which is very cool, right? So now we are started on our data science journey because we can now start slicing things by actual meaningful criteria. In particular, here's a simple example. If I wanted to find all the cities whose population is less than, you know, whatever number, pick your favorite number, 250,000, for example, then the only thing is you have to just read this carefully. The outer bracket is just the data frame. The inner bracket is the condition that I want to filter by. But what is nice is I've done a couple of things here. First of all, notice how I can get the column name by doing cities dot population. That is a nice thing. And I think even the notebook is kind of clever. See, notice if I type cities, it should actually, if it's not too slow, it actually is fast. And then if I do cities dot, it should actually somewhere help me and say that it knows that cities has a column called population. So instead of putting, so these are 2 equivalent ways. Either you can write this or you can write this. Now you have to pick a style and then use it consistently this way. And you can put cities data bracket, and then you have to do this if you want to actually use, like we were seeing before. You can these are equivalent statements. Give me this column. This is saying give me this column. And then it's a personal preference which one you like. I started off by thinking I would always prefer this, but as I started writing a lot of code, I started to prefer the dot notation. There's only one downside with dot notation, at least one main downside. Dot notation will not work if the name has a space in it. Population in whatever, in millions. If I had a name like this, I can only have a column access like this. I cannot do dot, of course, because Python will not take that as a valid thing, right? So this will be a problem for Python. We will not accept this. So then how do you survive? And the answer is, how do I survive is because I am in charge of all the names of my columns. I make sure that my columns never have spaces in them, right? You put underscores everywhere and then you get around this. But anyway, that's only a suggestion and it's a style thing. So I don't know what you would like to do. Ponder a minute, pick a style. The sooner you pick a style, the better and more robust your code will be, okay? So that's it. So that part is okay. This I showed you before, right? The values are all NumPy arrays. So whatever we learned last time about NumPy, we can do directly by extracting the values and manipulating them. So for those who are more mathematically minded, you want to transpose things, you want to invert matrices, you want to do all kinds of cool operations, linear algebra operations, for example, just grab the NumPy values and use NumPy. You'll get a lot of performance and things will be good, okay? Okay, next concept. So now we know how to create data frames. We know how to access values in data frames. We know how to get subsets from data frames. We even know how to use Boolean filters to filter stuff. Now, how can I modify some values? So the answer to modification is actually kind of simple. If I say in one sentence, basically, if you can select any subset, then you can assign to it. Kind of a metaphor, okay? And you can change the values that way. For example, here I have df.ilock1 and then I set a value, okay? You can just play with this again. I don't know how much I can say in words. So just play. But now the more important thing for me to say about assigning stuff is that when you modify something or assign to something, always be clear about whether the data frame, for example, in this case, df1, whenever you do any pandas operation, especially the ones that modify values, you must always ask the question whether df1 is getting changed or a copy is being returned, which is changed. And that is a very important concept. I want to place the concept in your attention. And as you write code, this statement of mine will acquire meaning, okay? There are some situations where the data frame is modified, and there are some situations where a new data frame is created. And distinguishing those two are really important to us. But that will come a little later, okay? So I don't want to beat it to death right now. I just want to mention it, and some alarm should go off when you're modifying things in your head. Okay, next thing is how to add rows to a data frame, right? How to expand the data frame. So again, there are slightly overlapping functions here, like append and concat, for example. But you can take a data frame and just call append and pass another data frame. And I'll just add it at the bottom. Okay, so I'll just keep on expanding it. So that is kind of a nice feature. Another idea is that if you have multiple times you want to join. So there are many cases. In fact, it's a common question. I keep creating small sets of data and I want to keep adding it to a big data frame. How do I do it? And the idea is that you keep taking your small data frames and you put them in a list and let the list expand as much as you need it to. When you're done with all your additions, finally you call pt.concat. That is the fastest way to do this process. It's better than adding each time concatenating a small piece, okay? Because the memory allocation can be done more efficiently. Try it out and see if you, right now it's an artificial use case. You don't have a need to do this. So anyhow, I'm just showing you how concat can work. But concat in this example I showed you first, it adds everything at the bottom as new rows. What if you wanted to add everything as new columns? Now there is a new concept. When there are operations, if the choice of whether to do it by row or by column is unclear, then by default, I think Pandas goes always to perform by rows. And if you wanted to perform the operation by columns, you must specify x is equals 1. X is equals 0 is for rows, x is equals 1 is for columns. So if we read this again in English, it says, can you please join these two data frames, but join them along the column axis, not along the row axis. Okay, and by default, if nothing is said, it joins by row axis. Okay, so far so good. Now let's see some fun stuff. Vectorized operations. This is really cool, right? You want to add the values in two columns of a data frame. You could just say, column 1 plus column 2. And what Pandas does is kind of mildly miraculous, cool. it matches by index location, lines everything up correctly, and then adds them for you, right? So for example, if you want, I'll give you a minute to look at this, but I want to calculate the population density. Again, this is a metaphor quickly for all of you. We belabor with basic things and then suddenly we can do something quickly advanced, right? I want to calculate the population density for the data set that I had before. And the answer is kind of trivial to do in Pandas. You simply take this column and you divide by the area, right? And that gives me the population density. And notice if I run this operation, I want to assign it to a new column. So here is the new column getting created. It's called the density column, and its values are to be computed in this way. You see the data frame now has a new column with a population density. And that in a nutshell starts to become, how do we actually do analysis? Well, just like in spreadsheets, you write formulas or whatever, here we will start writing computations like this, right? And then if you have a few computations, then this whole thing can be automated and lots of cool things can happen. I think this is a theme here. I don't need to beat this to death. You should already expect this and expect me to tell you this. But if you do vectorized operations, so for example, in fact, you can write it if you have the patience or the interest. You could write this whole thing by doing for loops in Python. You take the first value in a for loop and divide it. First of all, the code will be kind of large. And secondly, it will be 1,000 times slower, or at least, 500 times slower. Right, so this not only wins in elegance, but also wins in performance. And that may be the killer pitch for all of you. Why Pandas? Because our code will start to look like this. Why all the pain of ilock and lock and all kinds of things? Because then we will write code like this when we come to doing our analysis. And it will be fast, kind of an implicit guarantee, or faster than us writing simple Python code. Okay, and then of course there's some example here. You can time the performance, etc. Okay, now let me show you something even more powerful. What we did in SQL. So some people are interested in this. You can decide if you're interested or not. What we did in SQL, now we can do in memory, right? Inside the Pandas data frame. So here's our previous example, our SQL example. I went to the SQL database. I pulled all the data, right? And stored it in, okay. There should be something miraculous here. Can everybody understand how a data frame came out here? Or can somebody explain how a data frame came here? We were querying a database, right, from SQL. So SQL doesn't produce data frames. So how did a data frame come out? Importing would have been nice. No, actually notice, I actually made the data frame. See, I just changed one line of code. But as soon as somebody saw that, yes. So as soon as I changed one line of code, suddenly I have written a very powerful function. What that function says is, give me any database, because you can change the name of the database here. Give me any database and any SQL command, and I will convert it into a Pandas data frame for you. That's just 4 lines of code that has made this beautiful little thing for me. And I think it's beautiful. You guys can let me know if you think so, right? But I want to share that with you. This course is about being able to go out in the world and do things. And whenever we can write small pieces of code that give us capabilities, right? In this case, I can stop worrying about SQL. Now I can focus on my data frames. I don't have to worry about where it came from. Suddenly my code takes a big jump in quality. So hopefully you can see that. So here's the idea. So I pick a SQL statement. I run this query. It goes and gets everything, puts it in a data frame for me. Now I can work with the data frame. I can filter. You can do all kinds of cool operations now on the data in your hand. But in particular, I want to show you now, what if I have 2 data frames from 2 different tables, and I don't want to do the join, or I didn't do the join in SQL. The answer is we can join them inside Pandas. And in particular here, I'll show you this, although this course is not about spending all our time doing joins, but here is a Pandas join. Pandas has a function called merge. You pass in one data set, you pass in another data set, and you say which column do you want to use to be the join key. Right, so like SQL joins, Pandas will do the join, and here's the merge data set. I think this demo should convince you that we can do some really cool stuff inside pandas, right? And of course, if you ask as a competition, I have a database and I have pandas, then it becomes a detailed question. When should we do it in the database and when should we do it in pandas? If you're interested, you can ask me, I can tell you. But for now, you don't need to focus on that question. You need to just master the ability to do this in pandas, because in some cases, at least the data is not coming from any database. It's coming from a bunch of files or from a web page. And so there's no SQL that you can run on a web page, right? So you have to pull it in your pandas code and be able to link up things so you can actually do your data analysis, right? And that in a nutshell brings us to where all of the capabilities, right? So the rest of this thing is about doing all this, all these different operations, right? Merge operations, basically. But that's a good moment for me to pause. I think we're also getting to time, right? But how does everyone feel about pandas now? So let's see. Okay, so let's see. Now that we have discussed pandas, do you understand how to use pandas for data analysis? Some of you, yes. Okay. Okay. Yes. So please, I think you're saying the right thing, and you know it, and I don't have to repeat it, but it's still the most important piece of advice I can give you, right? It's very hard for me to take all my insights about pandas and just give it to you, because you won't even absorb it, and it'll be mildly boring. But I think that if you actually manipulate stuff like in the notebook and write code and let it break and try to understand things, it'll get fixed in your mind much better. So in fact, I've tried to make the course practical, right? So even though I gave you some kind of theoretical data frames in the beginning, I end the session with an actual real data set of some kind. It's not even that real, but kind of real, and plenty of code for you to write. And actually, I don't want to go through this now, but if you go back, I don't know, maybe I can mention it. If you go back to the website, which I'll just show you, you don't have to follow me all the way there. But the actual assignment in that section on processing data, if you go there, that assignment is, the lab is basically doing this, right? It says, can you please take a data frame and do something to it and blah, 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 right? So you can actually go and do all this stuff. And by the way, there is a nice little, maybe you can save this for next time, but there's some nice little analysis for you to do, which may be a little bit advanced, so we can do some of it next time. So take some time, ask me questions, send me emails if you have anything. But I will pause for a minute, catch my breath, and see if you have any questions at this moment. Someone should have a question, right? If there's not a question, a comment. Is everyone tired? It's been a long day probably for all of you, right? About lab 1, how many attempts? Okay, so my goal is to give you infinite attempts, but I want to tell you something very important. The goal is not to keep on hitting submit, right? There's no purpose to this. So the goal is for you to try to pass as many tests as you can and then hit submit. At that point, you can submit as many times as you want, but it's probably wasting your time, right? So I would suggest to all of you, really try to use this, right? Understand the tests, understand the question. I think, I really want to highlight to all of you, because I wanted to make you completely self-sufficient, right? Understand the question. In fact, me included, all of us spend far too little time in real life understanding the question. We're all trying to get to the answer. But this is a word of wisdom that you will only appreciate when it has meaning to you. But I still have to say it. Understanding the question should be the place where we spend a lot of time, right? In fact, you should take a chart and you should plot over time. When if 100% is total time spent on a problem, how much time was spent on the question and how much time was spent on the answer. And you'll find almost always in the beginning that we spend far too much time on the answer. That's because we didn't ask the question, understand the question properly. So spend time on the question, then understand the tests. The tests are there to guide you. and write your code and look at the test results, because the error messages in the tests will tell you where the problem is. And the reason I gave you tests is so that you don't have to panic, right? Get used to seeing errors in tests. They just mean that something needs fixing. So calmly take a deep breath, look at the error messages, and I assure you that the mindset, especially for those who are new to programming, the mindset that says, when I see an error message, it is not an issue. It's there to tell me something. If I can figure it out, I can fix it and be done quickly. So take a deep breath and read your error messages from the tests carefully, and your work will get done faster and faster, right? Once there are no more error messages, you passed all the tests, hit submit, you'll get 100%. Right? So those who do this like this, very cool. Let me know if that's what you end up doing. If you hit submit and you think you got the right answers, you are confident you got the right answers, but you don't get 100%, then let me know and I will try to fix it over time. Okay, notice that I'm also writing code, so there could be bugs. So if you find anything that's not working, but don't panic anywhere along the way. And also don't waste too much time. If you've done something that you think is 100% correct and the silly computer is not giving you 100%, don't spend 4 hours staring at the screen and figuring out what the hell it is. Right? If you find something is not performing the way you need it to, send me a note and say, Vijay, I think this is the answer. Just only thing you must tell me when you send me a question like that is just tell me what is your user ID on codeboard and roughly when you submitted it, so I can go and look at your code. And then very quickly, I'll be able to spot what the issue might be and we can solve it together. So since I said the word, I saw an error message actually the other day trying to use. That's a good question. But what were you doing there? You have to, so this is a beautiful example. If somebody has error messages, you have to tell me the exact context, okay? Either show me the notebook, give me a link to a notebook, or, in codeboard, show me the page. Show me some code that you were running, because many things can be wrong, right? If you tell me something broke, I cannot debug it. But if you show me something concrete, I will work with you, okay? So that is an important thing. I said together, I'm here to be kind of a partner to make you successful. So if you're feeling any pain or any problems, send me a note and I'm there to help. Okay. Okay, so maybe that was a good note for us to wind up, right? So important thing for you, please don't hesitate to send me a note. Don't spend too much time solving problems you don't understand. We can discuss them if there are any, and I'm here to help. So with that all said, hopefully you'll have a good rest of the week. I know we have some kind of break coming up, right? And so in that break, please don't unplug. We just started our journey on pandas. The next one will be about doing some analysis with pandas and so on. So if you take a break from writing code here for another few days, you might it'll all look very different to you. So if you can continue to sustain your practice and keep writing code, even if you have some time off, that's good. And I'll follow up after this with an email. But with that said, I want to let all of you go, get some rest, enjoy the rest of your week, and I'll see you soon. Thank you.